Well, good morning, good evening, good afternoon, I suppose good night, depending on wherever you are across our lovely world. Thanks for joining us live here today for the one and only Serverless Office Hours. If you're joining us on the AWS Twitch channel, we welcome you. And also if you're joining us via YouTube on the AWS Events channel, thanks so much for joining. I'm Julian, I'm a developer advocate here at AWS. And today we're talking databases. Obviously, there's state that needs to be stored somewhere, even in a serverless architecture. Databases can be serverless too. So, Rob McCauley, welcome to Serverless Office Hours. You're a specialist solutions architect. How come you landed up doing what you're doing with DynamoDB, and sort of what was your journey to AWS?
Hey, Julian. Yeah, thanks. Great to be here. I joined Amazon about 12 years ago, first here in Boston, where I live, building the warehouse robots at Amazon Robotics. I didn't actually build them. I wrote the SQL that ran the assembly line, but I didn't know about DynamoDB at first. And then after a few years, I started to build my first Alexa skills. And I realized that the skill didn't remember what you said yesterday unless you tied it into a database. And being serverless, we used a lot of Lambda, and we used this thing called DynamoDB, which I was really intrigued about. I thought it was a cool kind of serverless database, and so I used it a lot to build skills. And then about 6 years ago, I asked if I could join the team as a solutions architect specialist. And so here I am.
Oh, fantastic. That's such a cool story, starting from literally, starting from the robotics to the storing state and, a solutions architect. That's awesome. We were just talking before we went live about reInvent. So reInvent is our sort of awesome customer conference in Las Vegas, sort of first week in December. Always very annoying for my American colleagues because it's straight after Thanksgiving. There's huge amount of work happening behind the scenes of putting on a great event. I think reserved seating actually happens. That's maybe the best thing to be sort of signed up for soon. Rob, you are also doing reInvent. I know you're doing some workshops. So yeah, tell people what's your involvement at reInvent so people can sign up if they're interested.
Yes, for sure. I'm doing a lot of builder sessions this year. So we have one called Applied Data Modeling with DynamoDB. I think that's DAT 402. We have another one called Vibe Modeling for DynamoDB. Another one called DynamoDB Design Puzzlers. I do with my colleague Jason. That's always popular. And I'll probably be at the expo hall in the booth too. So I'd love to see you if you're around.
Ah, fantastic. Come along. So vibe coding with DynamoDB. I mean, are the models good in doing the vibe coding and sort of getting the modeling right and RCUs, WCUs, all those kind of things and the patterns, or bit of care and feeding obviously you've got to do like with any code, but are you seeing good signs?
Yeah, pretty good. Yeah, we have a workshop already where you can go in and suggest a SQL model, like a relational schema, and it'll recommend how to code it in DynamoDB, how to move into a single table design, what are some migration strategies. So I think if you're new to DynamoDB, it'll be really helpful. It'll bring you much further along the learning curve and present you with some potentially a working prototype, which you can go and you can see if it works for you. You can tweak it at that point. But yeah, it's pretty neat to see like how much it can do to save you, those initial weeks of learning what DynamoDB does.
Cool, excellent. And remember, we are live here on Serverless Office Hours, so please send us your questions and your comments. In fact, tell us where you're from. We always love seeing where our global serverless and database audience comes from. We had Madan Kumar's already asked, why do I need to join the session? I know about DynamoDB tables, but what is special in this session? So in fact, Robert, why don't you take our first question, seeing you're the guru on what you're talking about.
Well, thank you, Julian. I will do my best. So yeah, we're here today to talk about DynamoDB's multi-region replication. It's a feature we have called global tables, where you can simply take a single region table and say, I'd like to have replication to another region in the world. And we do all that work in the background for you. So we'll talk about that, and then we'll also talk about a brand new feature we have called multi-region strong consistency, which gives you, like the highest levels of resiliency and RPO and RTO. We'll cover all of that. So should we jump into it?
Excellent. Yeah, absolutely. Who else we've got? We've got AP Mike Lee. Greetings, guys. Thanks for joining us via YouTube. We have Eerie Edits. Welcome back via Twitch. Daniel Habib, good friend from AWS down in Brazil. We do have actually a question just before we see the questions are rolling in. I've been answered from a Java Spring techie. What is the equivalent of using Python framework to connect to DynamoDB? Does getters and setters exist? So that was just quick straight into it, but
yeah, for sure. Well, there's the Boto 3. That's what we call the AWS SDK for Python. That's pretty good. That'll do retries automatically. And then on top of that, you have the choice to use an ORM, but we can debate that. I'm not a fan of ORMs myself, but I hear that Pynamo, P-Y-N-A-M-O, is one popular one that people use out there to abstract away the database and turn it into just getters and setters.
Cool. Well, thanks for the quick answer. Mike Lee joining from the UK. Thanks for the question as well before. Kanishka Dutta from India, welcome. And also from Munich. I'm sorry, I'm terrible with reading non-Roman alphabets. I don't want to butcher your name. But I just want to set the stage quickly from DynamoDB. And, every year we talk about Amazon Prime Day and, some of the metrics and milestones are going to happen. So I'm just literally reading from the AWS blog. I'll find a link and post it into the chat as well. But over the course of Prime Day, a whole bunch of sources made tens of trillions of calls to a DynamoDB API. Dynamo maintained high availability while delivering single-digit millisecond response and peaking at 151 million requests per second. So it's not even per minute, that's per second. And the secret, funny, weird thing is, Amazon Prime is just another tenant of DynamoDB. All the rest of the world didn't pause to give them some space. So yeah, Rob, those DynamoDB is pretty remarkable.
Yeah, it's amazing. We always tell customers there's no upper limit. We see tables with trillions of records, and I have one bank customer that has a feature store that has 1 million writes per second all day long, and it runs just fine. So it's it's nice to have that headroom.
Fantastic, yeah. So yeah, Rob, over to you. What do we? I know we sort of did. I was just bragging on your behalf and on Dynamo's behalf about the figures, but yeah, why don't we step into a bit more about DynamoDB and how it works?
Let's jump into it. Yeah, sounds good. So yeah, DynamoDB, what is it? It's a database. It's a cloud serverless database, and we invented it here at Amazon. And we published a paper a long time ago called the Dynamo paper that kickstarted this NoSQL revolution, led to things like Cassandra and MongoDB and Riak and others. And the idea was that we were having trouble at the time to scale our fleet of commercial database engines, especially in December when our traffic would double. It was just really difficult for folks to keep those up and running. And we wanted a simpler kind of database that would serve key value access patterns like get my shopping cart, update my cart, get the top 10 products, things like that, that we didn't really need a full-blown database engine for. So we created DynamoDB, and since we've released it publicly, we've gotten rid of those commercial database engines, and we run most of our company on DynamoDB today, including things like the AWS console, Alexa, fulfillment centers. So we call it a tier 0 service, meaning there's my device responding, but it's a tier 0 service, meaning if it's down, we're down. So it's if you're on DynamoDB, you're in good company, and it's highly available. And the other thing, too, is we have this global replication for even more resiliency that we're going to get into.
Excellent. Yeah, just referencing that original paper, I think it was 2007 when Dynamo paper was released or something like that. And actually, Werner Vogels, Amazon CTO, was a part writer on that, as a PhD person. And also Swami Subramanian, who is leading up a whole bunch of GenAI stuff at AWS as well. And he earned his PhD in computer science and was one of the co-authors on that paper. So there are still people at Amazon who were the co-authors of that paper in pretty senior positions now. So it's interesting to see how their trajectory started with DynamoDB.
Oh, that's right. I think that my proudest moment was when I knew Dr. Werner Vogels was going to come to an event. So I printed out that paper in advance, and then I met him, shook his hand, and I got him to sign it and do a selfie. So yeah.
Excellent.
Okay, yeah. So what is that? What did they build? How does it work? Here's a quick look at sort of the infrastructure of DynamoDB. Here's you writing some code on the left. Here's your connection. You connect to a generic endpoint. You don't really need to connect to any one host. There's no cluster. It's really just an API in the cloud, right? And then that's as far as you go. You do your puts and gets and queries from there. Now inside of the service, we store your data in 3 availability zones. So it's very resilient and durable. If any one AZ were to go down, we can keep running on just 2 AZs. And we also shard your data across multiple storage locations, vertically and horizontally. So, your table, the green table here might be spread out across multiple locations. Maybe the yellow table is better, but you can see how it's like sharded horizontally and vertically across the 3 locations. So what we're able to do is if any one host fails, Dr. Werner Vogel says like things fail all the time. And if we have a host failure or a disk failure, we just handle it. And we have other copies. Within about 1 second, we've replaced that third copy, and we're up and running. The worst you'll see is a tail latency that's a little bit slower than most other requests. And so let me just go through the pattern of writes, because it's kind of interesting how writes happen. So we do want to eventually store your data in 3 availability zones, but it doesn't all happen right away. What happens is when you do your write, we're going to try to write it to at least 2 out of those 3. One we call a primary, and then another one. So we have this quorum concept where as soon as we've written to 2 out of 3 AZs, we call it durable. We give you a confirmation back, and you can move on. And the third region will AZ will catch up usually within 1 or 2 or 3 milliseconds. And I think this is the genius of the architecture, because as things are failing all the time, this might be failing and being replaced. And any one of them can. So as long as 2 out of the 3 are there, the system keeps running and is highly available. And when you want to read now, you have the option of doing a default read, which could read from any of the 3 nodes, or a strong read, where you're saying go to the primary, or the quorum in this case, and get the latest value. So reads can either be strong or default or eventual, depending on your price. It's half price for an eventually consistent read, but you may take a chance of getting a stale read, or you could do a strong read. So that's it in a nutshell. That's what sort of allows it to sustain failures, but keep on humming. Now, let's take a look at, that's all true in a single region. Everything I just mentioned is in one region, like US East 1. Now we have this feature called global tables, which introduces the idea of multi-region replication. So if you wanted to have a copy of that table in another continent or multiple copies, you simply tell DynamoDB through an API call or go into the console and say, make a replica somewhere else. You wait some time, and we will move your data. We'll synchronize it. When it's ready, you will have now automatic replication, and it's near real-time active replication. So what that means is that as a developer, you can write to any of the regions equally. There's no one that's ahead of any of the others. They're all open for business, and they're all available. And with that, let's take a look at the RPO and RTO. So when we talk about resiliency and failure handling, we have these 2 terms: RTO, recovery time objective, and RPO, recovery point objective. I think these are common questions if you ever interview to be a solutions architect here. But the RTO is measuring how quickly you could fail over to another region. Is there any delay there in pointing to another data copy? And the RPO is how much data might be delayed or not there. So let's take a look in terms of this service interruption. So here we have a stack, a serverless stack, Julian, in one region with Lambda and API gateway. And we have callers, maybe they're on their mobile phones doing region writes, and it's all happy. Their latencies are good. And what kinds of failures, what kinds of events could take this down? It could be the database layer has a problem. It could be, there's a problem with the stack itself. It could be a different service. It could be part of the network. Doesn't really matter. The big question, I think, is this green line green or not, right? As soon as some part of the stack is not working, then the top level caller will realize that, and they will have a decision to make. It may be just slower than they expect. If it crosses that threshold where they don't want to use that stack anymore, and if they have a stack in another region, then they can simply make a decision and point to the endpoint of the second API. And if that's up and running and warmed up, then they're good to go. And what DynamoDB does is, the replication is nearly perfectly synchronized. So the data is already waiting there for you. There's no time to restore, to find the backup, take, a restore that could take hours, lose 12 hours of data because you only backed up once a day. None of that. It's there. The replication lag now would be about 1 or 2 or 3 seconds of data that is in flight at any one time. So let's take a quick look at that latency. Let's do our first demo, shall we?
Just one question on the, seeing you had stacks over there, is that your sort of best practice as well when you sort of have a vertically integrated stack and, say, for example, your DynamoDB is not functioning, you could route from the Lambda function in stack 1 through to stack 2 across the world. How do you think about, where your segregation boundaries are and, hairpinning across regions and things like that?
Oh, that's such a great question. Yes, I think it's When you come to when you're an existing database person and you've used databases, they're typically on hosts. Well, you buy one box and it certainly could crash, and you're ready for that, and so you swap out. With DynamoDB, it's very different, right? There's no one host that's going to fail. So if the service for some reason was not working, we don't recommend, at least I don't recommend, that you try that. So I would like to have the whole stack either be 100% there and healthy or not. The problems are if DynamoDB is down in one region, remember it's a tier 0 service, so it's also powering parts of Lambda, parts of API Gateway, certainly the control plane where you make changes to those services or add new instances. Those certainly may be at risk if DynamoDB is truly down. So I wouldn't rely on them necessarily if DynamoDB is all the way gone. That's one kind of data point. The other is that it's now you break this nice clean stack concept. If you have pointers going across the region, it'll be hard to recover from that. You have sort of a mix match of parts of your stack in different regions. So it gets messy. Me and the engineers in the DynamoDB team, we prefer to have an atomic stack and then make the decisions at the very top level. The end user humans, the workload callers, and if they are happy, good. If not, hopefully have another stack ready to go. But
cool, yeah, that's good architectural device. And also, I know you work with fintech customers. I used to work in the fintech space as well. And whether you run active or active passive is also another architectural decision. And I think we'll get onto the speed of the replication. And you could actually run live with both of these stacks at the same time. For example, that could be an example or not. Depending on your use cases and how complex you want to run things or where your users are in the world.
Oh, absolutely. Yep. That's right. In fact, stay tuned. We're going to get right into that concept of running the same workload in 2 different regions in just a little bit. But yeah, let's jump into the demo. So the first demo I'm going to show you here, this is called the LMR. In case you run the DynamoDB immersion day, we have this available for you as a customer. You can talk to your account team. We can set this up for you. But what I have here is a simple web app, HTML app, and it just got some JavaScript in there to call these APIs that I've plugged in like that. And each API is just the API gateway of one of these stacks. So I have a stack in US West 2. I have another in EU West 1, which is Ireland. Right? And I can ping them just to make sure the Lambda is warmed up. And you can see the latencies there. And this is the latency from my house in Boston, so a bit of an internet round trip time as well. And you can see when you do DynamoDB, and typical latency there is pretty good, sometimes under 10 milliseconds, once that's warmed up as well. So you see we have this simple kind of key value access pattern. We have a bookmark. This is a bookmark for something like a Netflix or a Disney Plus show where you're watching this show and called Ashland Valley, and this is your username, and the book you have starting at 0 seconds, right? If you want to plus that, you can bump the bookmark up and see the changes. And if you want to read that in another region, it's already there. So we see that it's truly replicating. So the first question is, can I show you the replication lag? So what I'm going to do is I'm going to bump the bookmark in the first region and then see how quickly I can read it in the other region, see if I can catch it being stale. That's definitely not going to work. Let's try it again. From 4 to 5. So half a second since the update, and it's not there, but 4 seconds later, it's there. As you try this out, you'll see that it's, there we go. Sometimes it's 0.7 seconds going that distance, right? That's 4,500 miles, 24 milliseconds for the speed of light to travel from Oregon to Ireland. So pretty quick. As you can see, so around a second we advertise. We tell customers 1 to 2 seconds just to be safe. So that's the amount of data that is in flight. Now, the interesting thing about DynamoDB is when you write, you don't wait around to see that it got there. You trust that it will. You're pretty sure it will, but you don't want to have slow writes, at least in traditional global tables. So your writes are going to be pretty quick at 10 milliseconds perhaps, and the replication will go to the other regions in 1 to 2 seconds. And that's sort of the rub. My big bank customers, they ask me to describe that a little bit more. What about that 2 seconds of data? We never saw it confirmed. If there was an instant failure, a moment after you wrote, do we know that it's definitely going to get there? So keep that in the back of your mind. The other thing too I want to show here is conflicts. So let's see, what bookmark are we at? 7. Okay, good. So let's try a conflict. I'm going to imagine you and your spouse are watching, a show, the same show on the same account, but you're watching at a different time. So your bookmarks are overwriting each other. So I'm going to bump this one up, bump this one down. And there we go, first conflict. So this one went from 7 to 8. The other region didn't know about the 7 to 8, so it thought it was still at 7. So it's going to try to take it to 6. Now we have a conflict to resolve. And the way the system works is it's going to look at these two, detect a conflict, and realize that one of these has to be the winner, one has to be the loser. So it's going to take the later timestamp, meaning this yellow region here, and it's going to prune the 8 from the timeline and make the 6 value the same everywhere. So that's the final value. Simple conflict resolution as well. All right, so with that.
So does that take time, that coordination back and forth to do the conflict resolution? Because there could be other reads and writes happening at the same time, or reads calculations and writes back. That seems that could get funky.
Yeah, it doesn't take too long. Where systems able to detect those as they happen, and the real question is it in that boundary of like 1 to 2 seconds? If they're the same exact item, going in different directions, then we are able to detect a conflict. I'm not sure exactly how it works, but all of Global Tables uses DynamoDB streams, our change data capture log. So there's a streams reader, and then the network is aware of other changes that are coming in towards it for the same exact item, and that's I think how it flags a conflict and starts its conflict resolution.
Cool. Yeah, Yevgeny, thanks for letting me know your name. How are race conditions handled when performed from different regions? So I think we've just been through the demo of that as well. But yeah, if you do have another question, let me know.
Yeah. All right, okay, so that's kind of what Global Tables was, from 2018 up until today, this year. Now I'm pleased to share with you that we have released this summer a feature called Global Tables Multi-Region Strong Consistency. So we still have Global Tables. This is just a new mode which you can choose if you want to set up a table in strong consistent mode. Now we're going to call the traditional mode multi-region eventual consistency, MREC. But with MRSC, strong consistency, the tagline here is RPO 0, meaning we think we have driven that risk of 2 seconds of data that's in flight and not fully accounted for right out of the system. And the way we do that is the same pattern, writes confirmed by a quorum of two regions instead of 2 AZs. And reads, you can do a read with a strong region as well to get the quorum value if you want. As compared to the traditional global tables where writes are just confirmed by your local region very, very fast. We trust that it'll get to the other regions. And strong regions are just in the local scope handled by the AZ strong read of a local region. So let's take a look at what that means with the architecture diagram. Here's a global table with multi-region strong consistency. So when you do your writes, you can follow the numbers here. Your application will write first to the local copy, right? There's no global endpoint is another thing, right? You just write to your local copy, your local replica in US East 1. And the system now will go ahead and write that to at least one other region. Once that's all finished, then step 4, you get your confirmation back. So it's good and it's bad. It's good because we're certain that it got into another region in case this region suddenly has an interruption. But it is going to be a slower read. And we're going to do a performance demo in a moment to see how much slower. And look, Julian, region 5, it looks like it's still eventually consistent. Even though we have a quorum of 2, the third is a straggler. So this region, may be 1 or 2 or 3 seconds behind. But that's okay. Keep that in mind too as we see the failover scenario. So if there was a sudden interruption in region A for any reason, the stack fails or the whole region fails or DynamoDB has a bad day, as soon as you make that determination and you decide to do your failover, you may fail over to any region. Region C seems stale based on the previous slide. So if you put your app there and you want to get the latest value of everything you saw confirmed, now you can do a strongly consistent read. And with this type of table, it's going to be checked against the 2 region quorum. So even though the region C seemed like it was 2 seconds stale, it's going to check with at least one other surviving region, and you'll get back the very latest value.
So before satisfying that read from the client, it actually checks with the other core room read to check that it is up to date.
Yes, exactly. Yeah, it's going to check the other quorum. It's going to it's also going to be a bit slower on the read, but you're going to definitely get the latest value that any other region had seen confirmed. And so there we go. There's the tagline of RPO 0. So anything anyone saw confirmed is still going to be there should a region completely disappear.
And you're obviously not having to set anything of, well, you said having to configure the tables and all those kind of things in the configuration, but yeah, you're not having to tell, oh, DynamoDB, by the way, you need to also check with region B to make sure everything's up to date. That's just beautifully handled by the system.
That's my favorite part. I think networking is my scariest part of the AWS cloud, right? That's my least strong skill. And so with DynamoDB, you don't have to do that much networking, especially when you set up these multi-region global tables. You just say, I want a replica here, and we do it all behind the scenes. So I love that feature.
Cool. Evgeny does come with a good question as well. If the region serving region B, the second replica, chosen to have the lowest latency because it's up to date, or the local read replica randomly, it seems like we would like to minimize the waiting time for the client. My original quick response to that, it'd be you have clients connecting to the regional endpoint, and so you have clients connecting to either B or C. You could choose with your clients, but you may not be able to make that quick decision, and you probably want to have clients connected to their local region and then waiting for DynamoDB to catch up rather than routing their requests over to another region. Or is that a simplistic answer?
That's absolutely right, Julian. Yeah, I think so. So right, there's no central router or decision maker for that. But that's one item is stale in region C, but another item might be part of written to region C before region B. So there's no telling which region is before or after any other one. So the safest bet is to just use a strong read. By the way, we are exploring this idea of somehow a single region might know that it's at the latest version and not need to check another region. But these are some research project we're working on. Stay tuned.
Excellent. So yeah, obviously, I didn't think of the scenario when the two regions are the quorum for something else, or in different scenarios. So they also need to just do a quick check to make sure that's up and coming. But also know, not for in the SQL world, Amazon Aurora DSQL, is using the sort of millisecond time stamping, and I know DynamoDB Global Tables uses that as well. I presume that's what it's using to check the up-to-dateness, most correctly. And I know, DSQL has done a huge amount of work to figure out what obviously that's a transaction-based system, are in flight and aren't need to be processed or discarded. There's actually amazing technology behind the scenes, I think, in both of these, just on understanding how accurate time can be and applying that to data synchronization.
It's really neat. Yes, that's right. Both DSQL and this multi-region strong consistency were built together, and there's an underlying service we have called MRJ, the multi-region journal. You can see a reInvent talk that Somu, our engineer, gave last reInvent, where he goes deep into this multi-region journal. But that's the secret sauce that's powering both of these, with precise clock synchronization and timestamp checking.
And in fact, fantastic that I didn't actually realize it was the multi-region journal, because I've spoken even at reInvent for about I suppose single region journal. For example, Lambda, deep in the weeds of Lambda, when it needs to do some synchronization between components across multiple AZs, uses our internal service called Journal, which is phenomenally capable. It's in some parts deliberately very simple because a huge amount relies on it, but the architecture behind it is amazingly clever to just be able to fail over things really quickly. So yeah, to know that that's now been extended into region is fabulous. I love how we build on our own primitives to make things even better.
Yeah, it is. It's neat. Yeah, you see the similarities. It's a hard problem to solve, but yeah, we do the same thing that DSQL does. Okay, speaking of that, the multi-region journal also enables us to do things like this. So I've had customers say, "This all sounds really good, Rob, but I only do business in 2 regions. I don't really have a third region, and certainly I don't want to be paying for a 3-region global table, which is could be more expensive than a 2-region global table." And so we also have introduced this idea of a witness region. And what this is it's a kind of a silent watcher. Here's the region C as the witness region in this. And when you set up a multi-region strong consistent global table like this, you tell the region C is the witness, and you at that point on, after it's set up, you don't see it, you don't notice it, and you don't pay for it. You can still do your region writes from region A or region B, but region C is still there in case of a disaster, and you still need to have a 2 out of 2 quorum, so it can jump in and serve and keep the strong consistency available. Because if you had a disaster in region A and you start writing to region B, now you're more vulnerable, because unless you still have a 2 out of 2 quorum, which we give you with the region. So.
Okay, so it is a silent witness. Originally, I was thinking, oh, it's just obviously keeping the configuration because it just needs to know the latest update to the table. But it actually does have a full copy of the table there ready for you to fail over if you need it. Wow.
Well, this is not quite, Julian. Yeah, it's not quite a table. It's designed not to, you don't there's no way to turn it on or to enable it. It's really always there as a silent witness. So the actual tables are in the blue here. But yeah, it uses the multi-region journal. I do think it has metadata that stores the log of all the changes, so it is able to do what it needs to do, but it won't ever be promoted into a real region.
Okay, but if region A does fail, would region C then come alive and replay the logs and sort of build up its database transactions, or not transactions, but from the log, or not? That's not the case.
Well, you can think of it this way: it's always alive, right? It could, and then if you write to region A and region C happens to be the closest to region A, your quorum write may go into region C witness. You don't necessarily know that, so it's always sort of there doing its work. So you don't really have to, in a disaster, you don't have to do anything special. The witness region just sort of is doing everything it needs to do to keep that at least 2 region quorum going for region writes, even if one region's fully gone.
Okay, so Ramesh does ask, DSQL multi-region in Dynamo is not quorum-based, right? It sort of is quorum-based. It does need to be quorum-based for a multi-region strong consistency. For multi-region non-strong consistency, you wouldn't need a quorum. Is that correct or not?
I'm going to have to defer on that one. I don't quite know DSQL as well as I should.
But just say for Dynamo, yeah.
Oh, yeah. So the quorum, the quorum, it provides quorum, even though you don't see it. It's always, it could be, involved in a quorum right. Sorry, can you repeat that question again? I didn't quite catch it.
Oh yeah, well, Ramesh is just asking, let's ignore the DSQL because, is multi-region DynamoDB is not quorum-based, right? I'm saying, well, it must be quorum-based, or is it only quorum-based for the strong consistency model, not the non-strong consistency model?
That's quite right. Yes, yeah. Looking back to, yep, exactly. So this one here with strong consistency, and a table is either in one mode or the other. So if you set up a table in MRSC mode, then it's certainly going to be confirmed to 2 regions, or a quorum of 2 regions. Inside each region, we still have all the same 2 out of 3 AZ quorum. So we have quorum on top of quorum. But yeah, we have 2 region write confirmation with the new feature. We have the traditional global tables, MREC, which just writes to a single region and then assumes it'll get to the other regions.
Okay.
And
so
we do
need a quorum.
Yeah. So no quorum there. Yeah.
Okay, and then schizophrenic web developers asking when we were back at the previous. So are the writes to region A directly replicated to region B? I think that yes, that would be the case.
They're replicated to one other region.
Oh, one other region, correct.
So what I understand is this write will go into it's almost the exact same pattern as the 2 out of 3 AZ. So the first region receives your write. It sends a broadcast out to all regions. Well, there's always exactly 3 regions, but it'll send the broadcast out to the other 2, and whichever one replies quicker will finish the write. Will be the 2 out of 3 confirmation. So it may be region B or it may be region C, depending on it may be the same distance apart. For example, it could be either.
Yeah, and I mean that's actually a fascinating architectural pattern where you write to multiple places, and the first one to reply gets a thumbs up that yes, it's written. And so it means if there is a failure, you're not having to check, are you up, are you down, are you up, are you down? You just, in fact, spray out those writes to many places. And the first to reply can get acknowledged back to your client. So yeah, any gray failures or latency or network latency or that kind of thing, you don't even have to figure that out. It's just, it's there. And then also if the data has been written to multiple regions, well, great, it's over there. The syncing process is going to sort that all out.
I think so. Yeah, it's neat how it's because of that pattern, it's able to take the shortest path in every case. Yeah.
And it's load balancing as well. So if a network link is saturated or something, it'll just, it doesn't have to pick another link. It's just going to try a few links, and whichever one works, job done.
That's quite right. Yeah, just like Werner Vogel's designed the original with 2 out of 3 AZs. We know that an AZ could be up or down. As long as we get 2 out of 3, and the third one, whichever it is, could be failing, we're good to go. Yep.
Just one question, because Peter Smith, who I know is in New Zealand. Welcome, Peter. Thanks for joining us again. Replicate data in 2 countries. How do I know which other countries my data will be routed through? Sometimes it matters. That's an interesting, interesting network point. And cheapest.
Networking point. Great question. Yeah. When you set up global tables in general, the network links are all our private fiber background. So we have redundant, private links between these, and how they route. I'm not quite sure, but we are working on roadmap items where we would have a global table that might have the ability to home parts of the table. Certain partition keys, for example, or sets of your data could stay in country and never replicate, while others will be free to replicate.
Okay, so interesting.
Yeah,
but no, good question. Good question, Peter. When you're running a global distributed network and you need to have failover paths, I mean, I'm sure there are multiple network links into each region per country, but what are the hops to get there, and is end-to-end encryption enough or not? Good one. We'll have to write that on the paper napkin and send it to some of our clever principal engineers and find that out. But that is a super interesting question.
It is. Yeah, it is. That's right. Maybe beyond the scope of this. Come to reInvent. I'm sure we can put you in front of those principal engineers. We could have a chat about it. The other thing we've tried to do with multi-region strong consistency is not break anything. So it's really similar APIs that before. Default reads, strong reads, normal writes, or as a write doesn't change very much. So the couple of things you'll notice is creating a table. You create the table, and if a single region table, it has to be empty to start. And then while it's empty, you can go ahead and run this command with the CLI, for example. Add these 2 other regions and set the multi-region consistency to strong. And it's as simple as that, or you could designate one even as a witness at this point. So pretty straightforward. Now let's take a look at some use cases for MRSC, and then we'll end up with a demo of the performance. You're probably wondering how slow are the writes now that they're going to 2 regions. But some of the use cases we've seen are like this. To set the stage, so DynamoDB, without any global tables, has this cool feature called conditional writes. So you can always put an item or update an item, but you might like to check pre-flight the state of the item. Maybe if there's an item already exists, you want to pause and stop and not overwrite it, or even more, you may want to do some sort of Boolean expressions. Like Julian, if I wanted to pay you £10 for lunch, and my balance was only £9. Then you could have a conditional write, deduct $10 from Robert's account if and only if his balance is starting off at more than $10. If that conditional expression fails, then abort the transaction, abort the write request. And where this comes into play here is you can have these ledger patterns, as you see here. So this is a DynamoDB table with a partition key, a sort key, and then some number of columns or attributes or JSON payload. So for a given account, maybe there's a set of transactions, sequence numbers, 1, 2, and 3 exist. And the way you can do a conditional write for a ledger is like this. So first you query and you limit 1 and find the last item in this collection. It's sequence 3. Then you let the user go onto their UI and make some changes to it and prepare that, stage that up as version 4. And now you do a conditional write to sort key sequence 4. But say, fail if it already exists. So write it if it doesn't exist. If not, give me a warning or an error. And this is what we call the optimistic concurrency pattern, or even some customers call it lightweight transactions, which I really like. So this is always strongly checked. This sort of check, the pre-flight check of what's there at your target, what its state is, does it exist, what are the Boolean conditions about the data in that item. That's all strongly checked automatically if you do a conditional write. And you only pay for 1 write capacity unit, even though we're doing that reading and checking for you. So this is a beautiful pattern because, as you can see, you can build ledgers. You can have multiple threads trying to write version 4, and only one will succeed. The others will be told to requery and try again. it saves you from necessarily using DynamoDB transactions. We do have ACID transaction as well, but you can sometimes get away with a simpler approach just with these conditional writes. So that all exists in a single region today. Now let's see how it applies to multi-region strong consistency. So the good news is these conditional writes are strongly evaluated with a strong read on your behalf. So as you do any write to one of these MRSC tables, it's going to write to 2 regions, and any pre-flight conditions you put on there are going to be checked with a strong read, and it's either going to succeed or fail based on the optimistic pattern typically. So with that, now, my bank customers are excited because they can truly build a consistent ledger where you have different workers in different regions, all free to write to the ledger, potentially writing similar items to the same, PK values. And because of that optimistic pattern, they know whether they're at the, advancing the state machine correctly or not. So that's pretty cool. Another great thing you can do is if you're able to split your workload up like that, if you do have, the same workload or similar workloads in 2 different regions, one of my customers does this. They want to be able to fail over easily, and they don't want to, take a weekend off and do a giant failover exercise, right? Those aren't fun. So what they do instead is they say, let's just always be failing over. Let's put 70% of our workload in region A, 30% of the same workload in region B. Maybe they're pulling data from S3 bucket or something that's in common. But they're doing the same workload, and they're able to use this multi-region strong consistency now to safely write to the same table. Whereas before they would have a write here, they would have 2 seconds of data in flight, at which point there may be conflicts and more problems. And what's even better is if you're able to build this little knob, Julian. Now this isn't something we provide. You still might have to build this, but if you know your workload and you can carve it up and send some of it here, some of it there, and turn that knob one way or the other, that's the ultimate goal, right? Because now you could easily turn it all the way to the right or all the way to the left in case one region becomes unhealthy. And so it's super simple to fail over because you're kind of proving it every day with the way this is architected.
Yeah, that's I've always liked the sort of active model because it's running all the time, and your tests and your failure is just inherent in the system. You obviously need to architect that you've got enough buffer for something that is going to fail. But yeah, I was in financial industry for years, and those weekends doing disaster recovery tests. When you fail things over and hope and pray and make sure that everything's working, you can do that all the time.
Yeah, that's right. Yep, it's not all that fun. So. All right, cool. With that, let's take a look at some latency expectations and some performance tests. So here's what Silmo shared at last year's reInvent. And these are design goals. These aren't guarantees that this is what the latency will be, but these are what we are aiming towards for the latency, at least here in the US, for these 3 regions that you can use for this type of table. And these are measured in milliseconds. So if you do a write to US East 2, it's probably going to be confirmed by US East 1, and it may add an extra 25 milliseconds to your write request. And same thing for strong reads. They need to check 2 regions, so similar behavior and performance. Right, the speed of light is part of it, but there's also the network delays itself. So what I'm going to show you in the demo here is a latency testing tool I wrote I just call it Tester, and it's going to show you some performance results that I've measured. And also there's a link there which we will put in the chat. This is the idea here is everything I'm about to show you is again not an assurance of what your latency will be. It's really just some tests that I ran and my results. Your mileage may vary, but we want to put this tool right into your hands so you can pretty easily run this, with a simple EC2 host, some JavaScript, and you can do a test of 1,000 reads and 1,000 writes. That's all you really need to do to get the latency patterns and trends. So with that, let's jump into the demo. It's a live. Oh yeah. So I was going to show you that this is truly is a live demo. I'm in this folder under the Amazon DynamoDB tools public repo. I've done my npm install, so now it's time to do npm run dev.
Cool. I have put a link to that in the chat at the moment. I can't seem to bring it up on the screen, but anyway, it is in the chat now.
Oh, thank you. Yeah, perfect. Well, it's right here anyway. Yeah, it's part of our Amazon DynamoDB tools. It's a tool called Tester, which you'll find in there. And then there's a whole set of 4 README files that show you kind of what it is. Take a DynamoDB test drive for this benchmarking solution. I like it because you can build scientific experiments. You can say, A versus B. Is strong reads better than default reads? Is it slower? Compare two things and see on a chart what that will look like. So let's take a close look, and I think it'll all make sense. So the idea here is, here's your compute host. Here's your DynamoDB table on the bottom left. Now in DynamoDB and in CloudWatch, we are able to measure the latency, at least as far as we can see it. Inside our service, we can tell you and report on how many milliseconds it took us to turn around that request. But that doesn't give you the full picture. You still have your compute environment, your EC2 host or container, plus the network in between there, and whatever environment you're running in. You don't necessarily know the actual latency that you're seeing or your application is seeing. So I built this tool to run next to your app in the same exact environment, run short sets of read and write tests, put those into a CSV file as results, store those in a bucket, and then on your laptop, you can run this little Next.js app that we're looking at right now to see the charts, the results of all your tests. And in the interest, I have that, we got the environment all set up here, but there we go. Let's see if this works. So we're going to do a quick test of 200 reads and 200 writes, I think. And we can see the latencies for each request there. And we see that this was test number 600 at the end. So let's come back here and refresh. There's test 600. It's just a bunch of writes. Now, when you think about DynamoDB latency, we don't guarantee a latency, and we do have tail latencies that are higher than normal. So it looks a bit spiky. It might look a bit scary in this view. This is just looking at the latency over time, over request. But when you plot it as a histogram, now it looks much more reasonable, because the vast majority of your requests are in this bell curve, with occasional ones that are higher. And and there's a summary of it. 7 milliseconds average with a max, and a P99 statistical numbers for you as well. So with that, let's take a look at some other tests I did. This one here is reads and writes compared, and you can see the histogram shows them both. And you can see that reads are generally faster than writes, but they're both pretty darn fast. When everything's running smoothly and you're doing small reads and writes of 1 kilobyte or less, it can be a pretty amazing performance, almost as fast, I think, as a memory cache. The next one will be looking at multi-region strong consistent global tables versus multi-region eventual global tables. So let's unpack this slowly. So let's turn off the reads for now and just look at writes. So you can see that the normal writes to a single region table or a traditional global table are shown there, under 10 milliseconds, and then maybe add another 25 milliseconds to get the strong flavor. So there's the two, 7 versus 27 milliseconds on average. And same thing for reads. Reads versus strongly consistent MRSC reads are going to be about the same, but maybe a millisecond or two faster. Now looking at the histogram here we can see some clear patterns. So to summarize this, the bell curve on the left would be single region operations or traditional global tables, eventual reads, and local writes. And then the ones on the right would be anything that involves two regions, all writes to a multi-region strong consistent, and all strong reads. And so then you can see the summary of the breakdown of the read and write request there. So it does seem to add maybe 25 milliseconds, maybe less. And by the way, if you like this tool, I went a little bit further, and I would start these tests at the top of a certain minute and then run the test for X number of minutes. And then from that, I'm able to go and make a request into CloudWatch itself and say, show me that server-side latency, subtract it from the average latency I'm seeing, and plot a chart like this. So you can see how much time the network took versus how much time the actual DynamoDB service took. You can see that for the average, min, and max, and so forth for each type of request. Okay, and you can do other things too. This is looking at reads, strong reads versus default reads, a bit slower. And on the x-axis here is looking at the item size. So this experiment shows you a 1 kilobyte read, a 50 kilobyte read, all the way up to 400, our maximum item size. And with this, we can now use our linear regression statistics to figure out what the prediction formula is for an item of size n. You could predict what the average latency will be before you even build it. You could make sure everyone approves that latency. My banks always ask me, can you guarantee a latency will be under X milliseconds? I say, I can't quite guarantee it, but I can give you some statistical tools to help you figure that out for yourself. This one here is showing writes. Writes seem to be they add a bit of latency as you get into these higher item sizes compared to a default single region write. But for one, the single 1 kilobyte items, which are very common, we saw that it's only 20 to 25 milliseconds worse. Conditional writes, because I love conditional writes so much, I love it as the lightweight transaction model for ledgers. I decided I was wondering one day, are conditional writes any slower? It does have to do a read before it does its write. Are they slower? Does that slow you down? And what I found based on my own testing here is they're not any slower at all. I guess as we're getting ready to write, in either case, we must look at what's there or what isn't there. And so it doesn't have a penalty to do a conditional write. That's nice. And this is also doing conditional writes with MRSC tables. So I was wondering, if a strongly consistent write does a conditional write, is that going to also do a strongly consistent read and even bump the latency up even higher? And to my delight, I found out it doesn't change that at all. So looking at the summary here, you can see the summary there. Both regular MRSC writes plus MRSC writes that have a conditional expression seem to be the same latency. So no reason not to use conditional writes if you're building distributed workloads or ledgers or things like that. And then, the rest are just some other write experiments I was running just to show that it works. So there we go. So there's a quick summary of, I think this is the money slide here with the patterns. So you can run this tool on your own and let me know your feedback. All you need is a bucket and an environment to run it on. And let's go back to here. I think we have. Are there any questions, Julian? Or I have a couple more slides to cover. If not.
Well, just quickly, we have, obviously, as you were going through the demo, Schizophrenic Web Developer says, I think writes are slow, but most apps reads often than writing data. And, that's the general consensus, unless you're doing some sort of data warehousing or some kind of thing where you're storing data. That's generally what happens. So we do that. There was a question before about just failovers. Let me find that again. Sorry, I'm hunting around because I couldn't find it. Something about if there was an issue. Here we go. Schizophrenic Web Developer again. Does Dynamo have an option like write concern? So if the write to region A cannot be replicated to region B and C, you get an error message and the write is not successful. Do we assume that another region must be up and running or connectable to?
That's right. Yes, exactly. So if you have an MRSC table and you do a write to region A, it's going to fail if it can't also perform the write to region B. So you have that assurance. Mm-hmm.
So you do actually have the write concern when you're using the strong consistency for that same region as well.
Yes, that's right.
But it's just to reiterate, cannot be replicated to region B and C. It's one of region B and C because it just needs to replicate to another region, and then that's going to confirm the write. So Schizophrenic Web Developer, it doesn't have to confirm to both additional regions, just one.
That's right. If you had an MRSC table or MREC table, then it would write to the single region. And if there was some sort of network problem and it couldn't write to other regions, then it would still accept a write, prioritizing availability and the CAP theorem. This data would pile up on the DynamoDB streams on all these sides in a kind of a split brain scenario. And once that was solved, we would automatically recognize that, compare the DynamoDB streams, compare all the changes, and merge everyone back to identical, applying any conflict resolution for same item writes. So yes, designed to always accept writes, except if you're an MRSC, and then it definitely has to be in two regions.
Okay, and then AP Mike Lee also asked a following question: does rollback occur when if a break place takes between regions? What is the implications? My understanding, there's no rollback. There's always roll forward because the writes are always going to be confirmed in a single region, and those writes are then just replicated in an additional region. It's going to handle the merge conflicts, and it is going to just make sure both regions are up to date with that quorum. Is that correct?
That's correct. Yeah, I never really thought of it in that way. Thanks for the question. You might think that it writes to region 1 and then it writes to region 2, and then you have this mixed scenario. But it's almost like a transaction here. It's using the multi-region journal for sure. So there's an intermediate layer that we're not showing, but it's going to succeed in both regions or neither region. But you'll never have it in partial state.
Only in one region. Makes sense. Yeah. And then Peter Smith says, good architecture question. Because of the increased latency, is it worth using a combination of both strongly consistent and regular global tables at the same time, depending on the importance of each field in your data? And is it each field in your data or each table?
Yeah, so right now it's tables either in one mode or the other. So you could have a table with MRSC mode, but that's going to behave that way for all writes and all in every case. So one of my customers, they've used global tables for a long time, and they always called that their platinum level resiliency. And now that this is out, they start calling it titanium level resiliency.
There always needs to be another level further up. No, great question, Peter. And I suppose this is architectural practices of what is your requirements. I know, some companies, for example, not specifically DynamoDB, but even talking about data replication, where they have, financial transactions need to be always up to date. But configuration information or, even balances don't need to be strongly consistent, because, if the balance is slightly out, it's not really going to necessarily make that huge difference, but the actual individual transactions are going to be, or sometimes your balances do need to be strongly consistent. So yeah, it's working, and you may need to segregate your data in different kind of things to handle that. There's obviously a latency perspective, there's a cost perspective to that, and also an operational perspective. You may be willing to just pay the little bit extra because everything's in one table, it's easily referenceable. So yeah, the standard solutions architect, it depends, but yeah, as with the Dynamo, you need to think about your access patterns, think about what you're writing, what you're reading, what your failure scenarios are.
That's right. Yep, that's exactly right.
Cool, excellent. We've got probably a minute left. So anything else we're missing, Rob? What haven't we spoken about today that we should be?
One final thing to leave you with is this is from Sobu's slide deck. Imagine what kind of failures might happen on our end. With a 3-region MRSC global table, if a single region goes down, that we already talked about, that system keeps running. If there's a partition here and our network fails, at least one part of the network fails, system can keep running. All 3 nodes are still open for writes and open for business. If 2 nodes fail, if 2 replication links fail, meaning that now one region becomes totally isolated, then it can't accept any more writes because it can't give that assurance of 2-region quorum. However, the other 2 survivors can keep accepting writes as well. And I think that's all we have.
Cool. So yeah, you just need to remember it's always 2 out of 3. Always 2 out of 3. Even if it's within a region, it's going to be 2 out of 3, which is going to confirm. And if it's cross-region, always going to be 2 out of 3. Whatever's burning down, whatever. And if you're the one who can't confirm, you're not going to be able to accept the write. If someone else can't confirm with you as the second, they're not going to be able to accept the write. So
that's great.
Awesome. Well, Rob, super appreciate the time. AP Mike Lee has to jump to another meeting, but great presentation. Much appreciated, gents. I think the gent is meaning you're awesome means obviously Robert. So yeah, Robert, thanks so much for joining us today. Super deep dive into information with all the consistency and a multi-region and strong consistency and without strong consistency. I certainly learned a lot. As I've said many times before, this is my secret reason for doing all these live streams, is because I get to learn from the experts. So we appreciate you taking the time. Thanks, Rob.
It's been a pleasure. Thank you, Gold Mariners, and we'll see you next time.
Get the sports reference in. Everybody else, we'll be back same time, same place. I won't be your host. We'll have Gunagrosh who will be hosting, and we'll be talking about AI agents with a whole bunch of cool stuff being demoed next week. Goodbye, everybody. Thank you very much.